Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with the Indigo Girls and closer to find, getting closer and closer to find. Let's continue our journey with arguments and polar form with the complex numbers. Part 2. So we have some nifty properties of cis theta. Cis theta times cis phi is equivalent to cis theta plus phi. Nice. Cis theta over cis phi is equal to cis theta minus phi. These are not on your formula sheet. So these two, very simple, very easy. They're very similar to our rules for exponent laws. Okay, that's an easy way to remember them. And then this is common sense because remember, cis is just cosine I sine, yes? So if I have cis theta, yes, and I just keep going around 2 pi or multiples of 2 pi, it's going to be equivalent for k, an element of the z's. Okay, and here is the proof. Say yes. It's a lot of stories. It's a love story, baby. Just say yes. So you can pause and take a look at the proof if you would like. Okay. So let's move forward. So let's use these properties to simplify the wonderful, wonderful cis theta. Okay. So let's do A. Cis theta of pi over 5 times cis theta of 3 pi over 10 is equal to, did I say cis theta? That's wrong. Cis of pi over 5 times cis of 3 pi over 10 is equal to cis of pi over 5 plus 3 pi over 10. Could it be any easier? Okay, remember we're simplifying this. Keep that in mind. If we combine those, that's actually cis 5 pi over 10. Come on, do the fractions in your head. Don't be a big baby. Which is the same as cis is pi over 2. Right? Okay. Remember, cis is cosine I sine. Man, if you know your unit circle, you can crank this right out because this is cosine pi over 2, 0, plus I sine pi over 2, 1 times I, or 0 plus 1I, or simply equal to I. How about that? This is a lot simpler than this. What about this cowboy? Ooh, like our rules of exponents, this is equal to cis of pi over 5 minus 7 pi over 10. Yes? Everybody okay? Good. So this would be 2 pi over 10 minus 7 pi over 10, so that would be cis of negative 5 pi over 10, or cis of negative pi over 2. I really shouldn't have even written that, right? That's insulting to you. So that would simply be equal to 0 minus I, or negative I. Very simple, very easy. Giddy up! Simplify cis 107 pi over 6. Well, boys and girls, 107 pi, a lot of different ways to think about this. That's equivalent to, oh my goodness, a mixed number. 17 and 5/6 pi. Yes. 107 divided by 6 is 17 with a remainder of 5. Blah, 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 blah. Boys and girls, pi's over 6. We love those. So this is equivalent to 18 pi minus pi over 6, is it not? And maybe you already have the answer now. We're just kind of going through the motions and showing the thinking process, but this becomes, or we can think of cis 107 pi over 6, it sounds like a radio station, as cis of 18 pi minus pi over 6, right? Right? Which has to be equivalent to cis of negative pi over 6. Why? because 18 pi, boys and girls, is a multiple of k2 pi. I like 2k pi better. I don't know why folks do k2 pi. I like 2k pi. Whatever, okay. And what is, oh, come on, folks. What's the cosine and sine of negative pi over 6? Well, the cosine of negative pi over 6 is root 3 over 2. And the sine of negative pi over 6 is negative 1/2 pi. If you can't do that very quickly, unit circle, I'm saying, then you're in trouble. You need to get on it and take care of it. All right. So let's use the properties of cis theta to find the transformation which moves z to iz. Z to iz. So let's let z equal r cis theta. Isn't this nice instead of a plus bi? R cis theta, right? So then I, think of I as the complex number, just keep it in your mind, 0 plus I, or purely imaginary, okay? So I would be the same as 1, because it would be mod 1, would it not? 1 cis, and what would the argument be, boys and girls? What would the argument be? Think about that. How would you graph that vector or represent it with a vector? It would be right up on the y-axis, would it not? So the argument is going to be pi over 2. So 1 cis pi over 2. Nice. Okay. So then IZ would be equal to r cis theta times cis pi over 2, wouldn't it? Cis pi over 2. Okay, or zi, I guess, however you want to think about it. And what is that equal to? Well, isn't that equal to r cis theta plus pi over 2? Huh? 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 It certainly is, boys and girls. Okay. So that means, what does it mean? All that means is that z has been rotated, rotated in what direction? It's been rotated pi over 2 counterclockwise about the origin. Isn't that nifty? That is nifty. If you don't quite understand it, pause, think about it, and it will make sense to you, I believe. All right, let's go on to the big leagues here. Follow along. If we multiply complex numbers, the complex numbers z and w, z equals a plus bi, w equals c plus di, or z, r, think of this as r cis theta, right? Because r is equal to the mod of z. So mod z cis theta times mod w cis phi. Okay, two different angles. They'll have two different arguments. Okay. Well, this is equivalent to mod z mod w times cis of theta plus phi by, where is it? Right here, by this rule of cis right now, or right down here. Okay. Now these are going to be non-negative, so mod zw is going to equal mod z times mod w. And also, this is awesome, arg zw is going to be equal to theta plus phi, which is equal to arg z plus arg w. Remember, argument is just the angles, just the angles. So the upshot is, if a complex number z is multiplied by r cis theta, then its modulus is multiplied by r, and its argument is increased by theta. That is a lot to get your head around, and this example is showing this. So let's get right to it. Okay, so A, write z equals 1 plus root 3i in polar form. Okay, well, let's think about that. Polar form is r cis theta. Okay, and R is mod of Z. So square root of 1 squared plus the square root of the square, the square root of 1 squared plus root 3 squared is root 4. So that means that R must be equal to 2. Okay, hopefully you followed that. I'm sorry. Square root of 1 squared plus root 3 squared. I should have just written it out to begin with. So R equals 2. Well, what the hey is theta? What the hey is theta? Well, why don't we think about it like this? Okay, I'm going to go over 1 and up root 3. Yes? Over 1 and up root 3. Like that. Everybody okay? Good. So now we can say that Z is equal to 2 times 1/2 plus root 3 over 2 times I. Why can we say that? Well, if I go over 1 and up 3, yeah, so this is 1 root 3, yes. All I need is a sine or the cosine. Cosine theta is, well, let me see. We need the hypotenuse here, right? So this, we already know that R is 2, yes. So cosine of theta is 1 over 2, and sine of theta is root 3 over 2, okay? So now what do we do? Well, where does that happen? Where is cosine equal to 1/2 and sine equal to root 3 over 2? Well, that is at 2 times the cosine. Where does that occur? Please say you know it's pi over 3 plus I sine pi over 3. Got to know your unit circle, boys and girls. Right triangle trigonometry. Everything comes together in advanced mathematics. This is awesome, which we can write as 2 cis pi over 3. Beautiful, beautiful, beautiful. Now I'm going to go to B all the way over here. Okay. Hence, multiply Z by 2 cis pi over 6. Okay. So we are going to take, now we're just multiplying it to show that this is true. We're not really using any of this. We're just showing that this is true. So 1 plus root 3I, I'm going to take Z, times, what do they want me to multiply it by? 2 cis pi over 6. 2 cis pi over 6. Well, we need to get them in the same form, yes? Well, excuse me, we already wrote 1 times root 3I as 2 cis pi over 3. So this becomes 2 cis pi over 3 times 2 cis pi over 6, which we can write as 4, right? 2 times 2 is 4 times cis of pi over 3 plus pi over 6. Boys and girls, we have just shown that if a complex number Z is multiplied by R cis theta, then its modulus is multiplied by R, right? So here's R, and in polar form, 2 times 2 gives me the 4, and its argument is increased by theta. Well, pi over 3 is increased by pi over 6. So this becomes 4 cis pi over 2. Okay, and again, if you know your unit circle, this is very simple, very easy. 4 cis pi over 2, cosine pi over 2 plus I sine pi over 2 is equal to 4 times 0 plus 1I, or simply 4I. And what has happened on a Venn, or on a Argand diagram? Why did I say Venn? I don't know. Venn. Well, what just happened? Okay. Well, we started off with 1 plus root 3i, and it looked like this, right? So this was 1, this is a bad scale, and this is root 3. And then what happened? Well, we ended up with 4i. Let's go pink. Okay, so that's all the way here. Yes, so this is 4. Real and imaginary, yes. And we know that this arg is 2, correct? Well, here's what happened. We were at pi over 3, and then we went pi over 6 to get our argument. We just increased by pi over 6, and the r, or the modulus, was multiplied by 2. It was doubled. So that's what happened. Okay. And then what transformations have taken place when multiplying z by 2 cis pi over 6? Well, you can see right here, when z was multiplied by 2 cis pi over 6, I already said it. The modulus has been doubled, and it's been rotated counterclockwise pi over 6 units. All right, so that is it. Oh, you don't want to hear my downloads. Let's see how the Indigo Girls are doing. Hope you enjoyed it. I enjoyed it. I'm closer to fine, and I am out.